Okay, so today we are going to start graphing quadratic inequalities. So we've already done linear inequalities and we've done systems of inequalities. Now we're going to do curved quadratic inequalities. So all of our inequalities are going to be in the shape of a parabola. So everything we've done previously to graph them, we're still going to have to do. We'll just have the extra step of shading the correct solution set. So there are a couple steps that we can follow. These are just generic steps. The first step is to graph the parabola boundaries. This will be your usual parabola, except we'll have to decide if the parabola is going to be dotted or solid based off of the inequality that we are given. Once we've graphed it, we need to pick a test point that is not on the boundary line. I know previously we liked to use 0, 0 because it's really easy to plug in. This is no different. I still like to use 0, 0 for this because it's super easy to solve. And then just like before when we were graphing inequalities, if that 0, 0 makes the inequality true, we shade towards 0, 0 or the side that includes 0, 0. If it is not true, then we shade the side that doesn't include 0, 0. So if it's true, we shade toward the point. If it's not, we shade away. The steps are the exact same as when we were graphing systems of inequalities and just linear inequalities, except now we have a parabola instead of a straight line. Give you guys a second to finish writing that, and then we will get started with an example. Okay, let's go ahead and get started on our first example. The example we'd like to start with is y is greater than the quantity x minus 2 squared minus 3. So as I'm looking at this, I can identify what form this is almost in, right? So to me, this looks almost like vertex form. All I'd have to do is I would have to add the 3 over, which would give me y plus 3 is greater than x minus 2 squared. Why would I possibly want to do this? Or why would I want to see this in vertex form? How could that help me at all? It's going to help me graph it, right? In order to graph a parabola, I have to know the vertex and I have to have other points. So if it's in vertex form, like this one pretty much was, it allows me to easily identify that my vertex is 2, negative 3. So I already have 1 point for my parabola. For the purpose of shading for inequalities, I'm not going to require you to have 5 points. 3 will be sufficient. Okay, this is only for inequalities that I will allow you to have 3. So I have 1 point. I need 2 more. Technically, I only need 1 more because I can find its match on the other side of the line of symmetry, correct? So then I can kind of just pick a point. I can plug in a random x value, or I can go for one specific graphical characteristic, and I'm going to go for the y-intercept here, because I think that that's a really nifty thing to have or to know. So to find my y-intercept, I'm going to plug in 0 for x, and I'm going to solve it out. I'm going to go back to the original form it was given to me in, just because y is already by itself on the left-hand side, which is fantastic. So I'm going to use equals here too, because I'm trying to find a point, so the inequality doesn't matter. I plug in 0 for x, and I go ahead and simplify it out. 0 minus 2 is -2. -2 squared is 4. I get 4 minus 3, which gives me 1. So my y-intercept is the point 0, 1. So I'm going to take this vertex, and I'm going to take this y-intercept, and I'm going to put them on my graph. So what I'm going to do is I'm going to put those points on here. My first one was my vertex, so I go to 2, -3. I don't have to put the dotted line here because it might interfere with my inequality, but we still know that the vertical line going through my vertex is my line of symmetry, right? That isn't changing. I put 2, -3. Now I need to put my y-intercept, which was at 0, 1. Now that I have my y-intercept, I can find its match on the other side of my line of symmetry in the same spot. I have 3 points. That is sufficient for today. So I'm going to go ahead and I'm going to draw my parabola. What did I do wrong? Think back to inequalities. What do you have?
You made it a solid line instead of a dotted line.
I made it a solid line instead of a dotted line. How do I know that this is supposed to be a dotted line?
Because of the greater than or lesser.
Because of my inequality. Remember, if it is a single inequality, so it's a greater than or it's a less than, it is supposed to be a dotted line. If it is a double inequality, so if it's greater than or equal to or less than or equal to, then it is a solid line. So I need to go back and make sure I fix that. That is a very easy thing to forget. In fact, I forget it all the time. So I need to draw this dotted line. It still has the same shape. It's just dotted instead of solid, which means I'm not including any value that falls on that parabolic boundary. So that was step 1. I had to graph it. Step 2 is to pick a point that does not fall on this parabolic line and plug it into my inequality. I like to use 0, 0 as long as my parabola doesn't go through that value, and here it does not. It gets really close, but it doesn't actually go through it. So I'm going to put an x here at 0, 0, since that's the test value I'm plugging in. When I plug it in, I'm plugging in 0 for x and 0 for y and solving it out. And I'm going to use the original inequality I was given. So I have 0 is greater than the quantity 0 minus 2 squared minus 3. I simplify it out. 0 minus 2 is -2. -2 squared is 4. Then I get 4 minus 3, which is 1. Is 0 greater than 1? hopefully we all know that it's not, right? So when I shade this, I'm not going to shade the side of the parabola that includes 0, 0. I'm going to shade the opposite side. Unlike a line, there isn't just like a side, like normal. The two sides of a parabola are inside or outside. Since 0, 0 was outside and my inequality was not true, I need to shade inside the parabola. And then I'm done. Any major issues with that? Okay, let's go ahead and do another one. My next inequality is y less than the negative of x plus 1 squared plus 4. Again, I recognize that this is really close to vertex form. And if it was in vertex form, I would easily be able to identify my vertex. So I'm going to finish it out. I'm going to subtract the 4 over, which gives me y minus 4 is less than the quantity negative of the quantity x plus 1 squared. From here, I can easily pick out that my vertex is the same number with the opposite sign attached to the x, so negative 1, and the same number with the opposite sign attached to the y, so positive 4. I need another point, so again, I'm going to go for my y-intercept. It just seems super convenient. So to get my y-intercept, I'm going to use the original inequality, and I'm going to set it equal, and I'm going to plug in 0 for x. From here, I go ahead and simplify. 0 plus 1 is 1. 1 squared is 1. So I get negative 1 plus 4, which is 3. So my y-intercept is 0, 3. I have 2 points, so I can go ahead and put them down and then find the match to my y-intercept. I put my vertex down first, which is at negative 1, 4. Then I go ahead and I put down my y-intercept, which is at 3. I find its match. And now I have 3 points. Since I have 3 points, I can go ahead and graph it. Am I using a dotted or a solid line for this graph?
A dotted line?
A dotted line, because again, I have a single inequality. So I use my dotted line. It doesn't have to be perfect, but I should be able to tell the general shape. Once I have it graphed, I go ahead and I plug in some point on my graph. Again, I like to use 0, 0 whenever possible. I can definitely use 0, 0 here because it doesn't fall on my parabolic line. So I'm going to plug in 0, 0. You could definitely use a different point if you wanted to. You don't have to use 0, 0. So I plug it into the original inequality I was given, and I get 0 is less than the negative of 0 plus 1 squared plus 4. I simplify it out. 0 plus 1 is 1. 1 squared is 1. Negative 1 plus 4 is 3. So I'd actually already done that work when I found my y-intercept, but it's okay to do it again. So I end up with 0 is less than 3. Is that true? Yes, 0 is smaller than 3. So I'm going to shade the side of the parabola that 0, 0 falls in. Okay, remember the two sides of a parabola are inside or outside. 0, 0 is inside the parabola, and this was true, so I'm going to shade everything inside of my parabola. And then I'm done. Any major issues here? Okay, let's go ahead and do another one. The next example is y less than or equal to 2 times x minus 5 times x minus 1. This has been given to me in a specific quadratic form. What form is that? Anybody? Okay, well this is our factored form, which means that it tells me what my x-intercepts are. So I already have 2 points on my graph without having to do anything at all. My x-intercepts are each of these set equal to 0. So I have x minus 5 equals 0, which means one of my x-intercepts is x equals 5. I have x minus 1 equals 0, so the other x-intercept is x equals 1. So right away, I can put those on my graph. Which maybe means I have to do a little bit less work, which is always nice. I can't just graph from those 2 points though. I still need to figure out what my vertex is. So I'm going to FOIL this out so that it is in my expanded form. And then I'm going to go ahead and do the negative b over 2a. So when I FOIL this out, I get x times x is x squared. X times a negative 1 is negative x. X times a negative 5 is negative 5x. Negative 1 and negative 5 give me a negative 6x. And negative 5 times a negative 1 gives me a positive 5. Then I go ahead and I distribute my 2, and I get y is less than or equal to 2x squared minus 12x plus 10. So from here, I'm going to go ahead and do my negative b over 2a to get the x coordinate of my vertex. My b term is negative 12. The negative of negative 12 is positive 12. My a value is 2. 2 times 2 is 4. So this simplifies to 3. So my line of symmetry and the x coordinate of my vertex is 3. Now I need to take this 3 and I'm going to plug it back in for the x's in my equation. So I get y equals 2 times 3 squared minus 12 times 3 plus 10. Simplify it out. 3 squared is 9 times 2 is 18. 12 times 3 is 36. And then plus 10. Negative 18 minus 18 minus 36 is a negative 18, plus 10 is a negative 8. So my vertex is at the point 3, negative 8. So that's going to be the last point I need to graph this parabola. So I go to 3, and I go down to -8, and I put my dot. Is this parabola going to have a dotted or a solid line? Solid, because this is a double inequality, which means it's including everything along my line, my parabola line. So I go ahead and I draw this. And then I pick a point on my graph, plug it in, and check, and then that will tell me where I'm shading. Again, I'm going to use 0, 0 because it's super convenient. And it clearly does not fall on the line of my parabola. I'm going to plug 0, 0 into this version right here because it's pretty well simplified. So when I do, I get 0 is less than or equal to 2 times 0, which is 0, plus -12 times 0, which is 0, plus 10. So I get 0 is less than or equal to 10. Is that true? Why, yes. Yes, it is. So I'm going to shade the side of my parabola that includes the point 0, 0. Again, the two sides of a parabola are inside or outside, and 0, 0 is outside. So I'm going to shade everything that's not inside of my parabola. And then I'm done. Does anybody have any major issues with this? Any major questions or concerns either? Okay, there is one more example on here that we're not going to go through. If you want another practice, you're free to go through it on your own time. But there is one other thing that I would like to cover with you. It's not on your homework, but we will do more with this, okay? So it's not always graphing as the only way that you're going to solve things. There are also algebraic ways of doing it. So I'm going to show you the algebraic way of solving these are some types of inequalities. So the first example I'm going to start with is x squared minus 3x is less than or equal to 18. When we are solving inequalities like this algebraically, we're always looking for the zeros, okay? In order to find the zeros, I have to be compared to 0. So my first step is always to get all the terms on one side of the inequality and have 0 on the other. So on this one, I'm going to subtract the 18 over, which gives me x squared minus 3x minus 18, which is less than or equal to 0. Then to find my zeros, you could always use the quadratic formula, or we could just go ahead and factor. So I want to do the factoring because I feel like we could use the practice. When I factor this, I'm looking for two numbers that multiply to -18 and add to a -3. What do we come up with? Somebody.
-6.
Yeah, sorry.
I got -6.
-6 and +3, right? -6 plus 3 is -3, so that works out. -6 times 3 is -18. So this factors into x minus 6 and x plus 3. Those are my factors. They are not my zeros the way they're written right now. To find my zeros, I have to take each of those and set them equal to 0 and solve. So I have x minus 6 equals 0, and I have x plus 3 equals 0. I solve for x, so I get x equals 6 and x equals negative 3. So now that I have found my zeros, I need to set up a number line. On this number line, I'm only interested in those two zeros, so negative 3 and 6. Sometimes you might only get 1 0, in which case you would just put it on there once, and then we would just have two sides. This number line corresponds to intervals of values. Okay, and we've broken it up into 3 sections. These 3 sections are everything smaller than negative 3, which we write as negative infinity to negative 3. Everything between negative 3 and 6, which we say is negative 3, comma 6. And everything larger than 6, which we write as 6 to infinity. What I'm going to be doing is I'm going to be testing to see which of these intervals is a solution to my inequality or fits my inequality. So on this specific inequality, I'm looking for values that are less than or equal to 0, which means I'm looking for which intervals give me negative answers, because I already found my zeros, which are negative 3 and 6. So now I'm looking for the intervals that are going to give me values that are smaller than 0, which are all negative. To do that, I need to pick a number from each of these intervals and plug it in and solve. If it comes out to be a negative number, everything on that interval will give me a negative. If it comes out to be positive, everything on that interval will give me a positive. So I'm just going to pick random numbers. It doesn't matter which ones you use. So I'm going to pick negative 4 for values that are smaller than negative 3. I'm going to pick 0 for values between negative 3 and positive 6, because 0 is between there. And I'm going to pick 7 for values that are larger than 6. Again, you can pick any numbers you want as long as they are on those intervals. So I'm going to go ahead and plug in negative 4. It doesn't matter really which one of these you decide to plug it into. They're all going to work out the same. So when I plug negative 4 into the x squared minus 3x minus 18, negative 4 squared is 16. Negative 4 times a negative 3 is positive 12. And then minus 18. I go ahead and I put all of that together. 16 plus 12 is 28. Minus 18 is a positive 10. So I know the entire interval from negative infinity to negative 3 is going to give me nothing but positive numbers. Then I go ahead and I plug in 0, doing the same thing. 0 squared is 0. Negative 3 times 0 is 0. And then I just end up with a minus 18. That's negative. So every value on that interval is going to give me a negative answer. Then I go ahead and I plug in 7. 7 squared is 49. 7 times the negative 3 is negative 21. And then I have minus 18. 49 minus 21 is 28. Minus 18 is a positive 10, which is positive. So every number from 6 to infinity is going to give me a positive answer. Once I have done this part for the number line in positives and negatives, I need to look back at the inequality and what it was asking for. So this inequality was asking for values that were less than or equal to 0, which means negatives. I only had one interval that gave me negative values, right? And it was this one right here between negative 3 and 6. So I know that my solution interval is going to be from negative 3 to 6. The last thing I have to do is decide if I'm going to have parentheses on these or hard brackets. And this is based off of the inequality sign. So if it is a single inequality, I'm going to use parentheses. If it is a double inequality, I'm going to use these square brackets. Ours here is a double inequality, so I'm going to be putting the hard or square brackets on both of those endpoints. So my solution interval is from -3 to 6, including -3 and 6. So this is your algebraic way of solving these. Any questions, concerns, or issues with that? Again, this part is not on your homework, but you're still going to have to know how to do it, so I figured I'd introduce it now. Okay, we're going to do one more just as a practice, and then I'll let you guys work on your homework. So the next one I'd like to do is x squared plus 11x plus 30 is greater than or equal to 0. This one already has all of my terms over on the left-hand side, so all I have to do is factor it. I'm looking for two numbers that multiply together to get 30 and add together to get positive 11. Who thinks they know what they are? Somebody's got to know.
6 and 5.
6 and 5, good. Again, these are my factors. They're not technically my zeros the way they're written right now. So I need to set each of them equal to 0 and solve. When I do, I get x equals -6, and I get x equals -5. So I go ahead and I make my number line. -6 is smaller than -5, so it goes on the left. Because I had two zeros, again, I have three intervals, -infinity to -6, -6 to -5, and then -5 to infinity. What I have to do next is I have to plug in numbers on each of those intervals and test them. So -7 is smaller than -6. -5.5 is between -6 and -5. And then -4 is bigger or to the right of -5. It doesn't matter which one of these two forms you plug it into. In the last one, I plugged it into this expanded form. So on this one, I'm going to plug it into the factored form just to show you that it still works. So I'm going to take -7 and I'm going to plug it in to each of these x's and then multiply the answers together. So when I plug -7 in for this x, -7 plus 6 is a -1. When I plug it in here, I get -7 plus 5, which is -2. -1 times -2 is +2. So this interval is going to give me nothing but positive answers. Next, I go ahead and I take -5.5 and plug it in for each of these x's. -5.5 plus 6 gives me a positive 1/2. -5.5 plus 5 gives me a -1/2. I multiply those together and I get a -0.25 or 1/4. That value is negative. So every number between -6 and -5 will give me a negative answer. I do the same thing with -4. -4 plus 6 is 2. -4 plus 5 is 1. 2 times 1 is 2. So this is going to give me a positive set of answers on that interval. Now that I have the number line with the positives and the negatives assigned, I go back to my inequality and what it was asking for. So this inequality was asking for values that were greater than or equal to 0. This is a double inequality, so I know no matter what, I'm using hard brackets on these numbers. And I'm looking for numbers that are bigger than 0, so positive. I have 2 intervals that gave me positive solutions, which means that I'm going to have 2 intervals in my final answer. Okay, so the first interval that worked is -infinity to -6. We always put a soft bracket or a parentheses on infinities because it's not a quantifiable value, and that we don't know what the number infinity is. So this interval is -infinity to -6, and -6 needs to have a hard bracket because that's a double inequality. If we have more than one interval, we put a U between them, which means the union of. And then the next interval that gave me positive values was everything to the right of -5, which we say is -5 to infinity, where -5 gets a hard bracket and infinity gets a parentheses. And then we are done. How do we feel about this? Do we super hate it? Do we kind of like it? What's going on?
It's a little bit confusing.
My feelings are mutual.
This is kind of like your first introduction into setting up domain intervals. So we're going to be doing a lot with domain intervals. So these types of intervals right here that fit whatever the criteria for the function are. So you should get used to them. However, I'm going to try and slowly introduce them to you. So you may hate them right now, and maybe you always will, but I'm going to try and change that. And this, again, is not on your homework. This is just information that you should have. So I still hope you wrote down the notes or these examples. If not, they are on the notes that are on Canvas. So from here, I'm going to go ahead and turn you guys loose to work on the homework. It's only, I want to say it's only like 6 or 7 questions. And it's all the graphing stuff that we did previously in the notes. Okay? If you have questions, of course, I'll be on the Google call until the end of class. And if you have questions after that, just email me.
Great. Can't wait to get started.
Oh, I bet you can't, Wackle. I bet you can't.
I've been waiting all day for this.
I appreciate the lie.
Yep.
Mrs.
Yeah, what's up?
Can I ask you a question from last night's homework?
Absolutely.
On number 6, I don't know what I did, but it does not look right for the x-intercepts.
Give me a second to pull up last night's homework, and then we will take a look. You said number 6, right?
Yeah.
Okay, what did you get for your x-intercepts?
I got 8 plus the square root of y plus 100 over 3, and then 8 minus the square root of y plus 100 over 3. It's
Oh
not
boy.
good. Yeah.
Okay. Do you have your work? Can I see it, or?
Yeah. Do you want me to just show you or email it to you? What do you? What
Just hold it up to the camera to start with, and I'll see if I